Hi guys, so here is the PowerPoint for Organic Chemistry 2. We're going to talk about how you identify and name these different hydrocarbons based on the different functional groups. So we're going to talk more about functional groups today and what they look like and how you're going to name them. So there's questions that go along with Organic Chemistry 2. You can find those in the notes. You can do them on paper first, and then you can submit them on Castle Learning for me. All of the work that you are doing is part of marking period 4, so you need to stay on top of your work. You need to make sure you are submitting things as soon as you can. You don't want to wait till the very end, okay? If you're missing work for marking period 3, you have plenty of time still, okay? You can still make up that work, so this way we can make sure that you get a passing grade for the third quarter. If you need to retake any of those quizzes, make sure that you message me first and I can set them up for you, okay? So the quiz that's part of marking period 4, that's the kinetic and equilibrium and electrochemistry one is up. If you haven't taken that, make sure you review using the Jeopardy board and you log in and get that done as well, okay? Here we go. So we are going to go through a couple of these different pieces here. I'm going to explain how you would go about drawing these different guys. One thing that you do want to keep in mind is that these are kind of like puzzles. So look at the name of the structure, pull apart what you know from it. So we see that there's numbers at the front. I see that they give some sort of accessory for it, and then they give me the main chain and the type of chain it's going to be. So breaking all of this apart, that 2, 2, or the numbers at the front, it tells you the location where your extra accessories are on the chain. Dimethyl, we're going to look at the table P chart, and that's where all of your prefixes are. We talked about the prefixes and the suffixes. You're going to look at that. It's going to show you that the meth or the methyl group means that there is 1. Now, notice it says di, and what do we know about the prefix di? It means 2. So it means that there are 2 single carbon chains or accessories that are on this main chain. Looking at the next piece of it, pent, we know that pent is the prefix for 5, and we know that that's going to be a main chain, so the final piece over at the end is the main chain, the big chain that you can look at. And then the last piece is going to be that ANE, which means it's an alkane, and then it has single bonds between the carbons. Okay, so as always, you want to make sure that you draw your main chain first. So I'm going to draw in my first 5 carbons, and then I'm going to look at what I have to add to it. So on the second carbon, so make sure you can do it in either order, so you can do from left to right or from right to left, it's up to you. You're going to go through and you are going to draw in each one of these carbons, okay? So I put the numbers at the bottom so you can see it. On the second carbon, so on the location, the second carbon, there is a methyl group. Also on the second carbon is where the other methyl group is. So that means on the second carbon is where all of your accessories or your methyl groups are going to be. So as a methyl group, I know that I am going to put in my first carbon, and then I'm going to put my second carbon in. Okay, so this is what your structure should look like. Your main 5, right? 1, 2, 3, 4, 5. And then you've got your first methyl group and your second methyl group. Dimethyl, meaning that there are 2 methyl groups on this. Okay, last thing, I put my accessories on. I put them in the right location. I drew my pentane chain. All I have to do now is fill in the hydrogens that go around it. So remember, carbon needs 4 lines around it. This first carbon here only has 1 line, so I'm going to fill it in with 3 lines around it, okay? Each one of them represents a hydrogen. I can fill those guys in at the end, but each one of these blue lines that I'm putting in is going to be for a hydrogen. So the one on the end, this carbon has 1, so I'm going to fill in 3 here. 3 on the methyl group on the bottom here. 2 on the third carbon on the main chain. 2 on the fourth carbon, and 3 on the fifth. Okay, so again, you can go through and put all of your hydrogen letters in, or if you leave them off but you put the lines there, we know in chemistry that that means that there's a hydrogen. Okay, so the overall formula for this hydrocarbon, again, it's a hydrocarbon because it only has carbon and hydrogen, is C7H16. Okay, looking at pentane, we're going to do the pentine. We're going to do the same thing. We're going to pull it apart, and we're going to figure out each one of the pieces. So I know the number. If there's a number out in the front, it's telling me the location on the chain of whatever accessory I'm about to find out. pent. I know that prefix because I know table P, and I know pent means 5. So that means I'm going to have 5 carbons on my main chain. Looking at YNE, I know that that YNE stands for a alkyne, which means that there's a triple bond somewhere, at least one triple bond somewhere in this. So I'm going to draw out my 5 carbons. And then from there, I'm going to look at the accessory. So I know there's something on this second carbon here. So again, if you want to go through, you can write out the numbers so you can get a better idea of which order you're going in. You can go from left to right, or you can go from right to left. It doesn't matter which way you order them, but you want to make sure you have the lowest possible number to start it. So for example, I don't want to say 4 pentine. I would say 2 pentine because that's going to be the easier one to identify. Okay. So 2-pentine. On the second carbon, all that means is that the second carbon is the place where your triple bond is going to be. So looking at my second carbon here, I know that the second carbon is going to be the one that has my triple bond, okay? So I'm going to fill those in on the second carbon. I'm going to put my triple bond in. Now that I've filled out that accessory, all I have to do is fill in my hydrogens, just like we did on the last one. Every carbon should have 4 lines around it. If it doesn't have 4 lines, you're going to fill it in with hydrogen. So looking at the carbons here, just so you can see a little bit better, this first carbon here, the reason that it doesn't have any hydrogens around it is because it had that triple bond already, and that triple bond is what forced it to have 4 bonds around the whole entire thing. So it's sharing 3 lines, and it has the 1 line to the first carbon there. Same thing with the third carbon here. It's sharing those 3 lines, and it's got the other one. It already has 4, so he's not going to have any hydrogens around him. The total thing, when you add all of your hydrogens on, it comes out to C5H8. All right, 3-ethyl 1-pentine. Okay, so there's a couple different things here. I know that those numbers out in front are telling me the location of whatever accessory I'm about to add, whatever carbons I'm about to add. Okay, ethyl, I know from table P that prefix eth stands for 2. So that means that I have an extra 2 carbons somewhere on my main chain. Looking at the final piece, I see that I've got pent, so 5 on the main chain. And I also see here that there is YNE at the end of it, which means that there is an alkyne, which means there's a triple bond somewhere in my chain. Now, going through, you're going to draw on your main chain first, your main 5 carbons, and bond them together. Going back up here, we see that on the first carbon, there is a pentine, right? There is a triple bond. I see on my third carbon, there is an ethyl chain. So what am I going to do? I'm going to add 2 extra carbons on this third carbon. Okay, so the main chain, 1, 2, 3, 4, 5. On my third carbon, I'm adding an ethyl group. I'm adding 2 carbon atoms. Okay, so I did my first accessory. My second accessory is on my pentine. It's on my main chain. On the first carbon, I have a triple bond. So I'm going to take my first carbon. I'm going to fill in 2 more lines because it is triple bonded to the carbon next to it. Okay, I've completed all of my accessories. All I have to do is plug in all of the hydrogens to make sure every single carbon on here has a total of 4 bonds. If I count all of the letters up, I see that I've got 7 carbons and 12 hydrogens, so C7H12. Okay, and for the last one, 3,3-dimethyl hexane. 3,3-dimethyl hexane. Okay, I know that the numbers are the location on the chain. I know methyl is going to be from table P. I see that meth means I've got 1 extra carbon somewhere. I've got a dimethyl though, so that means I've got 2 methyl groups that I'm going to have to stick onto my main chain. How many do I have in my main chain? Well, looking at the main piece here, hexane, I see that hex means that I've got 6 carbons on my main chain, and ane means that I have all single bonds. That's an alkane. If you don't know the ending alkane, alkene, alkyne, make sure you look at the PowerPoint from the other day where I go over how to use table Q. Okay, so put in your main 6 carbons, so your main chain, your hexane. I notice on the third carbon, I should have 2 extra accessories, so 3, 3. On the third carbon, I've got my first methyl group, and I have my second methyl group. Okay, so 1 carbon goes on the top, 1 carbon goes on the bottom. This main carbon here on this hexane, this third carbon, now has 1, 2, 3, 4 bonds around it. This carbon is happy. We know he's not going to get any hydrogens. Are there any extra accessories here? No, all you had to do was put in the methyl groups. So easy, all you have to do is fill in the rest with hydrogens. So every single carbon that doesn't have 4 lines around it is going to get hydrogens to fill it in. So all we have to take a look here. 2-butene. Okay, 2-butene. Okay, 2 means that I have the location on the chain where I have this extra accessory. But comes from table P. I see that BUT means that there are 4 carbons on my main carbon chain. ENE stands for an alkene, which means that there is a double bond somewhere in this chain. There could be more than one, but there's at least one double bond. Well, where is that double bond going to be? That's the number out in front. Draw on your main carbon chain, 4 carbons. You know that your carbons are going to have a double bond on that second carbon. So looking at your carbons overall, on the second carbon, he should have a double bond in here. Okay, are there any other accessories? No, all we have to do is fill the rest in and fill in your hydrogens. If you fill them all in, count them up, make sure every single hydrogen has, every single carbon has 4 lines around it. If you check it, you should end up with C4H8. Okay, looking at ethine. We see the ETH at the front. We know that that stands for 2 carbons, and I know that that means I have 2 carbon chains here. Okay, so YNE means that it is an alkyne. It means there is a triple bond. Eth means there's only 2 carbons, so I'm going to bond my first 2 carbons together. The only place I can put these bonds are between them, so triple bond right here. How do I make them happy? Fill in the hydrogens around the outside. 1 hydrogen on the first carbon, 1 hydrogen on the second carbon. The formula for ethine, C2H2. Okay, so functional groups. Think of them just like accessories. So before we were adding little carbons like a methyl group or an ethyl, those little extra carbons around it. Functional groups are the same concept, but they're not carbons that you're adding around it. Maybe it's an oxygen, maybe it's 2 oxygens, maybe it's a double bonded oxygen. And we're going to go through all the different ones that you can see. What it does, each different functional group has its own unique chemical and physical properties. So depending on what happens, depending on what you add to it, you could be making an alcohol, you could be making an aldehyde, you could be making a ketone. They change what the actual piece is. Okay, so looking at the different functional groups, we're going to look at a couple of them today. The first one is the organic halides. When one or more hydrogen atom in an alkane, so a single bonded carbon chain, is replaced with a halogen. So this is right from table R. If you don't have table R in front of you, I put it in the notes for you. I'm going to pull out each one of them. Looking at this example problem here, 2-chloropropane, same way you were doing it before. Looking at the main chain is propane. I know if I go to table P, prop means that there are 3 carbons. I'm going to put my 3 carbons in. 2-chloro, well, I see that there's that prefix on it, chloro, so I know that that's going to be a chlorine that I'm going to add. Where am I putting that chlorine? Easy, I'm putting it on the second carbon. So on this chain, on the second carbon, I'm putting a chlorine. Any other accessories? Nope, it doesn't tell me anything. So all I have to do is fill in the hydrogens on the carbons, only on the carbons. So looking at that first carbon, it should have 3 hydrogen around it. Looking at the second carbon, it should have 1 hydrogen. And looking at the third, it should have 3 hydrogens around it. You can fill in the letter H, your final product, should be CH3, CHCl, CH3. Okay, and that's exactly what this formula is that they're giving you in the example problem. They're telling you what the structure really should look like. This is how you would draw that structure. Okay, looking at alcohols, when one or more of the hydrogen atoms in, again, an alkane is replaced with an OH. So we're going to take one of the hydrogens and knock it off. How do I know what a alcohol is named? Easy. You're going to drop the E from the end of the alkane, so whatever we called it, propane, butane, pentane, whatever we called it, we're going to knock the E off the ending of it, and we're going to change the ending to OL. Okay. Again, looking at the example from table R, for an alcohol, you've got CH3, CH2, CH2, OH on the end of it here. Looking at the structure that they gave me, I know that propanol, I've got an OL ending, easy, it's an alcohol. Looking at the beginning of it, propane, so I know that prop means that there are 3. If you look at table P, it tells you the prefixes. Prop means 3. Okay, there's one extra piece here on the first carbon. Again, that's what that number out in front tells you. It tells you where this extra piece is, and the extra accessory is on the first carbon. Looking at that extra accessory, if it's an alcohol, if it ends in OL, it means that I have to add an OH to that first one. Look at my structure here. The reason that this O is attached to the carbon is because it's not that the hydrogen is bonded, right? That would be HO. It's telling you it's OH. The oxygen is what's bonded to the carbon here. Okay, as always, like we always do, we've got to make sure carbon is happy. You are going to fill in the hydrogens in order to make sure every single one of your carbons has hydrogens around it. Your final formula should end up being C2OH, C2H, CH3. Same thing that's written here. All they did was they put it at the ending. Same thing. Okay, for an ether, hydrocarbons with a single bond of oxygen in the middle. So ethers, think about it like you have things on either side. Okay, so it means that you've got carbons on either side of the oxygen. Just a little trick to help you remember. Okay, looking at the example from table R, we've got methyl, ethyl, ether. Okay, so how do I know that this is an ether? This one's pretty easy because the ending is always going to be ether, right? Knowing that, I have to set up my oxygen. It's going to go in the middle, and on the outsides is where I'm going to have my 2 extra pieces. Now, what are the hydrocarbons that are going on either side here? Easy. Look back at what the example name is. So methyl means that there is going to be 1 carbon, right? The prefix meth is going to be 1 carbon. So I'm going to stick 1 carbon on one side. On the other side of it, right, because for an ether, you have to have carbons on either side, I've got an ethyl group. And how many carbons are there in an ethyl group? Easy, there are 2. I can see that from table P. So I'm going to stick 2 more carbons on the other side. Last thing that we have to do here, you just add lines to put your hydrogens around it, but only on the carbons. Carbons need it. So looking at my first carbon over here, he's going to end up with 3 lines around him. This oxygen, it's not a carbon. It doesn't get hydrogen stuck to it. So we're going to go to our next carbon. This carbon gets 2, and our last carbon gets 3 hydrogens. Nice and easy. You can put the letter H around them so this way you can see it. The overall formula is exactly what matches up here. CH3, O, CH2, CH3. This is an ether. Okay, ketones. So I'm sure you've seen ketones if you go to the pharmacy or you go to CVS. You can see you can buy different ketones. This is an example of them. You'll find them in the vitamin section. Okay, they are hydrocarbons with a double bonded oxygen to the central carbon. So we've got a hydrocarbon, obviously a hydrogen carbon, but you've got a double bonded oxygen on the central carbon. How do we name these? So how do I know if something is a ketone? Easy, the ending of it will have an ONE. You just knock the E off of the alkane and you add ONE in place of it. Here we go. Looking at the example problem that is given here. 2-pentanone. O-N-E, I see that ending on it. I know that it has to be a ketone, so I know that this is the structure that I'm going to have to end up putting in. Okay, what about the main chain though? Where are the hydrocarbons in this? Easy, I see pent. I know that from table P, pent means 5, so I've got to have a 5-carbon chain. Now, how are we going to accessorize this? What are the extra accessories on it? Well, I know that it's a ketone, so I know that it has to have a double bonded oxygen on that central carbon. So all I'm going to do is find that central oxygen, find the second one. It's telling me the location of it. Where should this be? And it's going to tell me where I have to put it. That double bonded oxygen should be on the center. So this is the exact structure. Do you see how there's that carbon here? On the second carbon, all you're doing is making that double bonded oxygen. Last rule, as always, we can see that the R and R on both sides, it's just saying basically the rest of the compound. So there should be carbons over here, there should be carbons over here in a ketone. Okay, kind of looks like a keyhole if you were to put a key into a door to open it up. You've got an oxygen double bonded to a center carbon. So it could have been on the second, the third, or the fourth one, not on the last or the first carbon. It had to be on somewhere on a center carbon. Last thing, as always, we fill in the hydrogens. So 1, 2, 3, 1, 2, 2, and 3. We fill all of these in. And this is what our structure looks like. Okay, this is a ketone. This particular ketone is 2-pentanone. Okay, organic acids. They are hydrocarbons with a double bonded oxygen on the last carbon, and it also has an OH in place of that last hydrogen. Okay, so this one's got a lot of extra accessories, we'll say. It's got a double bonded oxygen, it's got an OH. How do we name them? So how do we know that something's an organic acid? Easy, there's no E on the end of it, so we knock the E off of the alkane, and we add an OIC acid. So, for example, looking at the example problem that is given on table R in the reference table, propanoic acid. So this originally was propane, but it is now propanoic acid. How do we know it's an acid? I see that OIC ending. I know that it has to have this particular functional group in it. Okay, next thing I'm going to do, I'm going to look at the beginning of it. Propano. Okay, I know prop means 3, so the main chain is going to have 3 carbons on it. What extra accessories am I adding here? Well, I know that it's an acid, so I know that there has to be a double bonded oxygen and an OH. But where does that have to be on an organic acid? Look at the instructions. It has to be on the last carbon or on the first carbon. It can't be anywhere in the middle. So you could put it on this first piece over here, or you could put it on the ending over here, and you will see that it becomes carbon with a oxygen, double bonded oxygen, and a hydroxyl group. Last step, fill in all of your hydrogens. Okay, an aldehyde is a hydrocarbon with a double bonded oxygen on the first or the last. So it's kind of like the opposite of a ketone, we'll say. It can't be on the central carbon, it has to be on the outside. Here we go. How do we know that it is an aldehyde? Easy, it's got an AL ending on the end. So if it's OL, it's an alcohol. If it ends in AL, it means it's an aldehyde. Okay, example problem again from table R, so you can see what these look like. I've got the AL ending. I know that that means it's an aldehyde. So it means it's going to have this particular functional group on it. It's got this accessory on it. Okay, how do I know how many carbons are going to be on the main chain? Easy, I look at table P. I've got that prop at the beginning, and I know prop means that there are 3. So I'm going to write in my 3 carbons. Now, I have AL on the end, so I know I have to put this piece in. It means that I have to put a double bond at the front or on the last carbon. So I'm going to put it on the last one just because I think it's easier to see it. I've got a double bonded oxygen, And now I just fill in the hydrogens all around. Same way we've been doing. Make sure that there are 4 lines around every single carbon, and that's what's going to make this happy. This is your structure for propanol, okay? So aldehydes, I'm sure you've heard of before. Formaldehyde, what we use as a preservative if you're trying to preserve a certain specimen. An aldehyde is what can do that. Okay, esters. They're double bonded oxygens on a central carbon with a single bonded oxygen. So if it's an ester, it means that it has 2 oxygens on it. It's got extra accessories compared to the rest of them. It's got 2 oxygens. Okay, how do I know if something is an ester? Easy. The ending of it is going to end in O8. So, for example, looking at the problem from the functional group on table R, I've got methyl propanoate. Okay, so I see that OATE on the end, and immediately you will be able to tell it's an ester. You have the reference table in front of you, so use it to your advantage. Okay, it tells you the names of it, it tells you the type that it would be, and it tells you what the accessory is that you are adding onto it. Okay, you're just accessorizing hydrocarbons here. Okay, I know that I'm going to add this group on, but I need to know what is the main chain that I'm putting it on. Okay, propanoate. Again, 3 carbon, nice and easy, 3 carbon chain. Now, I know that if it's an ester, it's got a double bonded oxygen on a central carbon, and it also is next to a single bonded oxygen. So basically what is going to happen here is that you've got your main chain. You are going to take your main chain, and on the very end of it, you are going to add your double bonded oxygen. Next to that guy, you are going to put the oxygen in, the same thing that the structure is on your reference table. You've got your 3 carbons, and then you've got your double bonded oxygen and an oxygen next to it. So this is going to make sure that that oxygen is in the center. On the other side of the oxygen, you have a methyl group. And what does a methyl group look like? It means that there is 1 carbon. So I'm going to take that 1 carbon, I'm going to stick it on the end of it. So this is ensuring that that oxygen is staying in the middle. Once you've drawn your structure, all you have to do is fill in your hydrogens. So as always, make sure every carbon has 4 lines around it. Fill in as many as you need to make sure that you've filled in all of your carbons and they're happy. So this is the structure for methyl propanoate. So just to go over a couple organic chemical reactions. Combustion is the first one, and you should be very familiar with this. It happens when a hydrocarbon reacts with oxygen and you produce carbon dioxide. So all of these definitions you are going to need to know. Substitution reaction, it occurs when an alkane, so that hydrocarbon, and a halogen, so something like chloro, fluoro, anything from those halide groups, it reacts so that 1 or more hydrogen of the alkane is replaced with the halogen. All that it means is that you are substituting in any of those groups. Okay, a substitution, pushing somebody else in. An addition reaction is when you are taking an alkene or an alkyne, so a double or a triple bond, and you are combining it with a halogen to make one product. So again, hydrocarbons, taking a halogen, anything from that halide group, and you are producing one product. Esterification, it's when an organic acid and an alcohol react to make water and an ester. Saponification occurs when an ester reacts with a base to make alcohol and soap. It kind of looks like the word soap. So saponification produces soap. Fermentation occurs when the yeast is catalyzes a sugar, and it makes carbon dioxide and ethanol. So it produces alcohol, but ethanol and carbon dioxide. So this is basically how they make beers. Polymers are these long chain of repeating units called monomers. So a polymer is just really, really, really long chains of these different hydrocarbon strains. Polymers form by polymerization reactions. Polymers, polymerization. A natural polymer can be starch, cellulose, or proteins, and a synthetic polymer can be any sort of plastic like nylon, rayon, and polyester. Those are all polymers. They're these really, really long chains of monomers. Okay, they've got lots and lots of these chains. So, yes, big words, there's a lot of chemical reactions here, but you just have to have a basic idea. The Regents does ask about it, and New York State does expect you to know these, but these are the basic organic chemical reactions. So if you need to, again, on Castle Learning, input your answers. If you have to draw them, you can use the toolbar, WRIS Chemistry. You can find that, and if you click on it, this should pop up. You should be able to put in your answers. If you're struggling with it, you can just send me a picture if you have to draw that particular structure and put the rest in on Castle Learning, okay? Again, this is for a single bond, double bond, triple bond. Okay, so use this today. Just go through this PowerPoint. I know it's a lot. Just go through this a couple times. And then tomorrow the work or the questions will open up for it. Okay, so you got 2 days to do it. One last thing, you are in marking period 4. Please don't fall apart now. You know that we're not going back to school, so I need you guys to be keeping up with your work. If anything comes up, if you have a problem, some of you have been doing a great job reaching out and coming to me when you need help. Some of you have not, so make sure that you guys are doing everything that you can to stay on top of your studies. All right, guys, I will talk to you tomorrow.